Hello, hello everyone. We are back for today's session, and today's session will be in last 1 week. I have uh, completed. So as you know, we are working on our certified Kubernetes specialist course, and we have been trying to document the progress that I'm going to make, and this is the second recording in this uh, series. So, in the last week, I have learned uh, about a very important chapter, that is SSL. So, let's again quickly get into the uh, curriculum. So, here it says properly set up ingress with TLS. This TLS is transport-led security. Again, let me quickly see where the SSL is mentioned. Mm, mm. So I believe this is only the same with TLS. So I have learned, I have made a mind map for to understand what is the basics of TLS and all those things. So this is the mind map. So I will just be uh, explaining this in detail. So what is TLS, transport layer security? And TLS, what happens is uh, the data we share. Suppose there is a server and there is a user who's accessing the server. There is some application he's accessing. So there are multiple ways he can access. So for security standpoint, uh, the the traffic has to be encrypted. Okay, so uh, what encryption is, basically we have a key, uh, a hash kind of thing, and whatever data you're trying to send and receive, that key is imposed over to that data, and by this way the data is not readable to anyone else. So this is the concept of encrypting. So there are basically two types of encryptions. One is symmetric encryption, another is uh, unsymmetric asymmetric encryption. So in in symmetric encryptions, what happens is we make use of only one single key to encrypt and decrypt the data, and that key, a user creates that key and sends it over the network along with the data. So if any middleman is there who is sniffing that data, he can get access to the key, and all the data can be hacked. So for that reason, there is one more uh, encryption uh, that came into picture, that is asymmetric encryption. So in here, two different keys are uh, used. One is to encrypt the data, which is a private key, and another is to decrypt the data, which is public key. So this is basically a certificate process. Uh, the first thing is we create a certificate signing request. For this specific, we make use of OpenSSL tool, and I have given some commands in after in another uh, session portion. So this is just a small procedure, and once we create a certificate signing request, we send it to the CA certificate authority. This what CA will do is CA has its own public and private keys, and it will the CA will uh, assign that specific certificate with its private key, and it sends you the signed certificate back. Once the signed certificate is validated, so the CSR is validated thoroughly before the CA signs it, and it so that it knows that you're not a fake, you're not having a fake identity, and you are what you say you are. So how to know if the CA itself is legit? So this is CA has its own uh, public and private keys, and s- it's it signs the specific CSR with its private keys, and its public keys are built in all the uh, non browsers. So if you could, I could showcase the CSR here. So let me just quickly go through the settings, and here I have certificate and security. Mm. Here you can see manage certificates, view imported from root store, and here all these certificates are mentioned like root CA, and there is this bypass class 3. There are certgen, you can see certgen as well, DG cert, all those certificates. These are public keys, and public keys are access. Public keys are stored in the by default it's stored in the Chrome. So So what CA does is any third party CSR comes to it, it checks what crowds it uh, uh, signs that certificate with its private key, and then it sends it to the CSR provider with signed certificate. When we try to connect to that third entity, first the third entity sends the public key to user along with the CS signed certificate. Then the user with CS private key that we I have just shown in the public. Uh, then the user with CS private key decrypts the data and finds third party's public key. Then the user generates symmetric key for further traffic. This symmetric key is encrypted with. So I was just taking an example of HDFC banking. So let me quickly show you how it works. If I type in here HDFC net banking, not here. Let's take new incognito. HDFC net. Okay. So if you could see here, we can see connection is secure here. Certificate is valid. We can open this and we can see that this specific certificate is issued by DigiCert to HDFC Bank, and the validity on this certificate is about 1 year. So you can, when you see DigiCert has issued the certificate, it means DigiCert has is the CA for this one. And when I try to log in now to HDFC Bank's portal or anything, so at that time, what it will do is the next stages. And then when try to connect the entity first, the third entity sends the HDFC Bank sends its public key along with that certificate, and then the user CA's private key decrypts the data and finds the third party's public key. Then I, as an user, generate a symmetric key for further traffic. This symmetric key is encrypted with HDFC's public key, and that was sent on earlier step. HDFC decrypts the data is with private key and retrieves the symmetric key. Secret. So basically, this is the uh, basics. I'm not entirely clear on these basics, but we will dig deep after in this one. And the next is TLS in Kubernetes. So TLS is required in Kubernetes. In Kubernetes, we need to understand which component talks to which other component in this environment, so that we will be getting an exact picture of how many or where the Kubernetes certificates, sorry, the TLS certificates are required. So there are two uh, segregations in here. One is server component and another is client component. So basically what server components are, the server components that talk to other components on behalf of the control plane or on behalf of the Kubernetes itself, like kube API server. It talks to all other components. So it's a server component. It's CD server. It talks to kube API server and it saves the data. So it's a server component. Again, the kubelet. It talks to worker nodes. So kubelet is also a server component. So what is client components? That we as an admin talk to kubectl or talk via kubectl or API. We are a client to the Kubernetes. Schedulers that talk to kube API. Kube controller managers that talk to kube API. Kube proxy also again talks to kube API server. So these are client components. So anywhere in someone, so basically anywhere any component is talking to any other component, it would need a private and public key to encrypt and decrypt the specific uh, traffic of the data. So this is cert. This is the way we can generate certs from OpenSSL. First is generate key for uh, CA key only. So this is OpenSSL gen RSA out CA key. Then we create a CSR. Then we again set the CSR with own key, sign key. That is, and once we get the CA and signed CS assigned key for Kubernetes, then for clients we create the CSR with root CA. That is this command. So I have come up to this in my journey. So just wanted to record this and put it out to the world. If you have any questions, any suggestions, feel free to reach out in the comment section and share your thoughts on it. Thank you. Have a great one. Bye.